Welcome everyone to the webinar of Zero Swarm, and it is the final webinar since the project is running till the end. And yeah, we are welcome. We are ready to welcome you at this final milestone. So thank you for joining. Let me introduce to you our presenter. This is going to be Chris Lee, our dedicated partner from SMS Group, and he's the senior project engineer who is going to guide you through the one of the trials of the central node of Zero Swarm project. So without further ado, let me hand over to you, Chris. And
Thank you very much.
let me also remind to all of you that this session is going to be recorded. It will be available on YouTube afterwards. So if you have any consent regarding this, please let us know. And do not hesitate to ask your questions after the presentation of Chris. There is going to be the Q&A session, and you will have the opportunity to engage with the expert. So thank you in advance. Please, Chris.
Thank you, Katarina, for the kind introduction. So hello, everyone who doesn't know me. I'm Chris Lee. I'm at SMS Group. SMS is a steel plant builder. So we are not producing steel, but we are engineering plants for the steel business. But I will explain this in more detail a little bit later. And you're going to hear about how we, in our department, we get new sensor data from the shop floor in less than 5 hours with 5G connectivity. So let me introduce you first to the Zero Swarm project. If you don't know what it is, I will just introduce it shortly to show you what the premise of all the work is that we are here presenting. It's a EU-funded project. We have 29 participants from 10 EU countries, and the goal of Zero Swarm is to provide a framework that is modular, open, and reusable. And to achieve this, this future production that we have in mind, which is data-driven, so decisions are based on data. It's connected, so we want to have interconnected different parts, modular parts, and it's called CPSOS based. So cyber physical system of system is the basis of its modularity, and it should be trusted, which we say is safe for the people and secure in its integrity. And so this is the frame where we did the trial Katarina mentioned before. So this is it was quite a challenging project, but we as a SMS, and I hope our partners also, we learned a lot, and we had a lot of fun together developing the technical solutions. So now I'm going to show you what my partners directly in the SMS, what we are doing. So we have a lot of different use cases, usually regarding retrofitting and digitalization. So we are more or less part of the retrofitting business. We are looking at asset health. So here we try to insert real-time dashboards for the production. And the secondary use cases are connected worker. So we try to have a safe environment for the people who work in the factories. We look at safe crossings where you have autonomous vehicles together with humans working on the shop floor. And we are looking at the crossing situations, vehicle traffic, automated traffic, and how to make it safe. And we are also looking into logistics, how to place certain things or store them as efficiently and automatically as possible. So as I said, the lower cases are the secondary use cases, but our main goal is to always find the right sensor that then to also place it and to send its data so that we can use the data or aggregate the data or use the aggregated data and to present an information or a decision, or even that's the most advanced case, to act on the presented data. So this is what we as SMEs do, or our part, or my part of the company. And the next slides, I will show you why do we even care about 5G? What is the advantages? What are the advantages of 5G? And we say these are 3 points, or 3 main points. We have a distributed network setup on the one hand. So you can have a centralized location for the computation intensive network core that you can use. But then on the outer, or on the edge, you can use lightweight radio units, which are mobile mostly, or can be mobile, and we use those as needed. So you have one centralized core and have as many radio units as possible. The 5G has a delegated administration model. So the benefit you get is that usually service provider maintains the 5G network functionality. So you don't usually need 5G capabilities or expertise in your business. And 5G is an open standard. So there are several private 5G offerings on the market, which of course gets you the cost benefits. But cost benefits are always relative. Maybe some of you know that 5G in itself, the installation of a fixed 5G installation is not as cheap as the industry would like. So I will show you now what are the arguments, the reasons why you should have a 5G for industrial applications. So first of all, if you use 5G, so it's separate from public or Wi-Fi networks, then of course you're also independent of those. You have an autonomous own network, which means that you have low risk of interference. Which also means you don't need to coordinate with other players in the network, especially in Wi-Fi networks. We see those in companies on the shop floor. If you have a more or less overloaded Wi-Fi network, then there's a high interference, and the latency that you need for certain automated functions is not given, so that it's too high. And so you get consistency and reliable QoS, or quality of service. If you have this 5G network, then you can slice the network as you need. For example, if you have high data traffic for video traffic, or if you have a lot of sensors, then you need to switch between the different players in your network. So this is something that private 5G gives you. And I already talked about it, the ULLC, so ultra low latency capabilities. So this means that you can, if it's needed, have certain latency up limits, which makes safety guarantees possible. It doesn't mean that you should do it, but you can consider it to have certain safety functions covered with 5G. And you can also, as I said before, prioritize important data traffic, which has maybe a real-time or near real-time component. So the next, the third point for 5G in industrial applications is that you have access to high quality cloud computing, because the data connection is so stable and so consistent. You can reduce the power requirements on the devices, and then get all the high computational tasks. You can move it to the edge cloud or even to the cloud. And this enables, of course, new use cases. Yes, of course, if there are advantages, there are always also challenges. One of them could be that you don't have the expertise inside your company, unlike Wi-Fi, where you, of course, have someone, an IT specialist or anyone who manages your network. You don't know about 5G as much. Because it's a mobile standard and it's not used in private households, etc. So maybe you could think this is a hindrance to use 5G. The next thing is that the benefits are not always clear, especially the tangible benefits that you can count or express in euros. For example, any cost savings, quality improvements, capacity increases, everything that you do with your production line. Some of those things can be measured in euros, but having certain functions or better machinery or better capacity usage on machines, they have benefits down the line, which is hard to grasp everything in total. And as I said before, the fixed installation with hardware and the setup cost of the software easily reaches 6 figures. So 5G has a high threshold for the decision to use 5G. As you can see, and as some of you may already experience themselves, so 5G is a hype technology, or used to be a hype technology, and but the adaptation into the industrial domain is not as well done or highly done as we would like it to be. So let me show you what we do in our trial for the Zero Swarm project. I will describe to you what we did in the trial, and then we will look at the results and what this means for 5G in industrial applications. So the CN stands for central node. So the Zero Swarm project is divided into different nodes to have a better overview. And in trial 3, which is where the SMS group presides over, has to go to prototype and test and scale new 5G-based use cases for manufacturing. Some of them I already showed you. So the main buzzwords are IoT and Industrial 4.0. And we would also do a mobile 5G network setup, which we can set up as a pop-up, so to speak, at new locations, so that we can serve our customers better, showing them certain things are possible, or this is the data that you get when you have a 5G setup, and to make this threshold that we talked about, the costs and the decision, what are the benefits, etc., to lower this threshold. So here you can see the schematic setup. So on the left side, we see different radio dots and the links between the server room. So more on the hardware setup between the server cores, the radio dots, and the server room. So I will show you later pictures of it. Here you have the cloud connection of the servers, and you have different 5G spots. And we use, of course, sensors. We have, for example, condition monitoring masters. We have 5G capable masters, and we have end devices. So this is for the fixed installation. Or what on the left side, we show the fixed installation. So when you go here, we have different kinds of sensors, like the Shopfloor Optime and the Treon, which I show you here pictures of. And here are the different kinds of condition monitoring masters we use. And the 5G capable masters, one of the boxes was developed inside the project itself. And of course, we have a lot of different end devices. And here is one of the most challenging things is to have these end devices. It's not always easy to get those into the network, to get those connected to the network, to get your data, to get your information, to get your alerts, everything that depends on those. And this is also what we tried to look at when we did the mobile installation, but let me do this a little bit later. So here's the fixed installation. This is our Lernwerk. Yeah, so let me So this is our Lernwerk, yeah, and you can see I have a better view here. We have different radio dots inside this facility. It's about, I think it's 25 to 25 meters, or maybe it was 40 by 40. So it's a quite a big or usual shop floor. And here we can do different things to try out different things, because it's a facility where we where we do education for our skills lab for workers. So here we have the fixed 5G installation, and then we also connected the machine to 5G. But I will show you this in a short while. So here, the next slide will show you. So I said we want to do a mobile setup. So what we would like to do is to go to customers, set up a 5G if the data that we are going to set up or extract from the machines, if it needs 5G or they are asking about 5G. So what we do is what we would like to do is do a mobile setup and also have all the devices that we need already implemented into this network. So especially the end devices, I told you that it is hard to, or sometimes it's difficult to get them into the network because they have different PLMMs, and some of them are not able to connect to so-called campus networks that are test networks, more or less. And so we have to work around some of the issues. And this is something that we can do on site at home. So we don't need to go to the customer and then trial and error at on site, but we can do it on site at home. And then if everything is set up, all the connections are done, or we know what we have to adjust or what we have to configure so that it works, then we can all pack it up, the IoT devices, the radio setup, and the cables, or the antennas, and then package everything neatly and is ready to go. As you can see here, this is not a lot of stuff, and you can transport it via car. So you don't need a big transporter or a truck to unload these things. You don't need a lot of manpower or muscle power to set everything up. So this is a quite new and neat solution to the mobile setup that we were looking for. So let me go into detail on those. So this is the IoT setup. You can see a wireless IO-Link master with a SIG sensor. SIG is one of our partners in the consortium. And you can see that here everything is set up. Here you can see the attached sensor to the machine. And inside the machine, it's a drilling machine. Inside the machine, there is the counterpart of the sensor. And then there's a cable to a wireless setup, which is then also connected to some data processing unit. So then here you can see the different cables. So we have cable antennas to set everything up on the shop floor. We use cable antennas. So we have one big antenna array, and then also cable antennas that extend the network, the coverage of the network. So these who are 25 meters each. And you can see there are connectors, so you can connect them and even elongate that to 50 meters or 75 and up to 100. We have cable antenna mounts. So we use standard equipment for music boxes or light, how do you say that, light trenches. So we can use standard equipment. And we also need a GPS antenna. That's always a little bit of a nuisance because you need a GPS signal to the radio core, to the radio access network, so that they can do time synchronization. But if you don't need time synchronization because you're just looking to get some data out of a single source, a couple of sources which do not have any time synchronization needed, then you can use an emulator. Because if you don't have a GPS signal, a real one or an emulated one, then you're not going to get your 5G operational. 5G needs GPS because the time synchronization has to come from somewhere, and this is how they solved it. And of course, this is a slight nuisance, but there are workarounds to this problem. On the next slide, you see then the array antenna, and we have an internet router. This is the case. This is the case with where you have the RAN at the core. Yeah, and here is the connection to the GPS antenna, as I showed you before. And this is the array antenna. And here is the cable. No, this is the power. And there is on the other side, there are the cables which connect the cable antennas to the big array antenna. Right. This is how we set everything up. And then I will show you our success story. So where did we end up? So we get 5G connectivity here also on the end device and also on the iPad of my colleague. And here you can see, okay, up there, there's a 5G system. Yeah, so we get 5G connectivity inside or on the shop floor successfully. So I will show you a video of what the of the whole setup. So this is the drilling machine. Inside there's going to it's going to be drilled, and then we will see that the data is transmitted from the sensor here over 5G to our data acquisition tool. So this is filmed by mobile camera, so not high quality, but you can see that there's a drilling, and then the camera looked at the data that is processing here over the 5G, and then it will look up to show that the 5G is installed, and there is up here there's the 5G system zoomed in by my colleague. Okay, the premise of this call of this webinar was to get data via 5G in less than 5 hours. So we have the data. Yeah, we have a Ubuntu installed with Dockers on the RAM. Yeah, and we use containerized data expert. That's our software that we use to analyze the data. So what this means is that we have edge capability, or that we have higher edge capabilities directly on the radio network. Yeah, so we don't need to have additional hardware to process this. We don't need anything additionally. Of course, you can connect to the cloud and use cloud capabilities. But if, for example, the customer and some of our customers do, if they say, we would like to do everything on premise, no data should go out because we are afraid of industrial espionage, etc., then you can do the setup where you have the Ubuntu on your RAN server, and everything is inside your premise. Yeah, everything that's a two-way street, two-way data traffic. So we get data, and we can also analyze it and visualize it. We have 5G. Yeah. I will show you, or we will discuss later, how good the 5G of this mobile setup is. And we have it in less than 5 hours. The whole setup took 2 hours and 20 minutes. As I said before, we could prepare everything. So all the end devices were already inside of the network. They knew all the network parameters, and we could have the data traffic. So everything was more or less set up, and we just have to go inside the shop floor and connect the power cables, set up the antenna cables, set up the tripods, so that not the cables are not lying on the floor and are any work hazards. So all the setup with two people in 2 hours and 20 minutes. And I think this is something which would be good to show people what the benefits of a 5G connection would be, um, and how fast it can be. And then with the data, they can make their decision. Of course, there are still some open points that we would we still have on our minds, and we need to look into. So, for example, we need to look at so we need to do comparison tests between the fixed installation and the mobile installation, because the mobile installation has around 200 mbits per second, in comparison to the fixed installation, which has 4 times as much, so almost 800 mbits, megabits per second. So there is a difference still, and we need to look into it more to understand why there is such a gap. We would also like to look at the network coverage. So how much is the coverage? So how reliable can we get 5G in all the corners of the shop floor? Of course, this is not, let's say, 100% is not distinctly or not in all cases better than, let's say, 80% of network coverage, because it depends on what the customer needs. And if they say, okay, in the corners we don't have any 5G cases, then of course a reduced setup could be even better, or could also be used. And what we also didn't do until now is a reliability of latency. So have a 24-hour check of the latency, so ping every minute or something into the network and see how the latency is 24 hours on the 24-hour period, just to see if there's a difference between the fixed or the mobile installation. We don't know the answer yet. We believe that the fixed installation has a higher reliability and a lower latency, but we are not quite sure. And this is still an open point we would like to investigate. The next thing is, this is something we are not able to do ourselves, to increase the convenience. One of the things we encounter a lot is that we have end devices and we are going from one customer to the next, and then we have to use a different SIM card, or we change the networks, things like that. And it would be much easier if we had eSIM cards directly assign SIM cards to a network carrier, and this would also make the device management easier. And we believe that you can also use this to make an additional miniaturization, so that the devices could be even smaller and use maybe even less energy, things like that. Of course, I talked about the GPS signal, which can be emulated for our pop-up system. But of course, if you need time synchronization, then there needs to be a better solution. So the customer has to have a functional GPS signal inside the shop floor, or has a long cable to the window or somewhere else where there is a GPS signal. And one last thing that is still open is that we need the so-called RedCap. RedCap stands for Reduced Capability. That's the part of the 5G standard which ensures that the energy consumption is reduced, so it doesn't use the whole capabilities of the 5G stack. it is used because then you can use smaller chips in the devices. And for example, you can have higher battery life. So this is also something which needs to be investigated or needs, yeah, something you have to keep in mind, that this is one of the challenges. All right. So that's all I have to say for this. And I'm happy to answer any questions.
Thank you very much, Chris. Indeed, if you have some questions, don't hesitate to either drop them in the Q&A section that you see on the screen, or to unmute yourself and ask them directly. And meanwhile, maybe while we're waiting for the questions, I want to share with you the link to the website so that you have also the entry point to all the information that we have, including the deliverables and the scientific publications, as well as the form to get in touch with us. Yeah, nevertheless, since even though the project is coming to its end, you still have all the materials available, and you can still follow what are the achievements and advancements of the project. Okay. No questions yet. Well, since there are no questions, Chris, I think that it can be a compliment to you that everything was very well explained.
I hope so. Of course, thank you for your attention. Please get in touch with me via my email address, or you can also add me to LinkedIn. I'm happy to answer any questions or, yeah, talk about collaboration or, yeah, anything that you need or want. I'm happy to hear from you.
Thank you very much again for the great presentation, and thanks to all of you who participated and listened, and have a wonderful day. Thanks again for your attention. Goodbye.
Thank you. Bye, everyone.